Hello everyone. Today I'm going to discuss the last problem of Leetcode Weekly Contest 437, which is a length of longest V-shaped diagonal segment. So the problem is we have given a grid of size n cross n, and we have to find a V-shaped diagonal segment of maximum size. So what is a V-shaped diagonal segment? The segment starts with 1, and the segment subsequent segment elements follows the infinite sequence 2020. So let's take one example. um, so let's say this example only. Let's say we have something like 1 to 1. Let me write something better. Let's say we have something like 202 1 20 122, and let's say 000. Now or let's say we can write it, this is 120, and this is 2. Let's say this is 0 and this is 0. Okay. Mm, or let me write it, this one is, let's say 0. Let me write it again. This will be 120, and we don't really care about other elements, so let me write all zeros here. Okay. So a diagonal segment can start with 1. So let's say this starts with, the diagonal segment starts with this one B step segment. So this goes to 2, and then this goes to 0. Okay. So the element segment starts with 2, and the segment can take at most 190-degree turn. So it has taken a 90-degree turn here, and the length of the segment is 3. So the answer of this will be 3. So let's take another example from this. Okay, here you can see that this segment starts with 1, and it goes in this direction, in this diagonal direction, starting with 2. So after 1 we should always have 2, and then we have 0, then we have 2, and then we have 0. Now 90-degree, here one important thing is that 90-degree turn, I thought that it would mean that we can turn in any direction, like I can go from, let's say I can go from here to here also, but that is not a 90-degree turn. According to the problem statement, we can go from here, then we can turn here. There are some combinations only we can take. uh, let's say we are going to this direction, then we can move to that direction, and we can also move to this direction and move to that direction, like that. That is what we have to keep in mind. Now let's jump to the solution approach. So let's take the n and m values are 500. So we have to solve this problem in around order of n m. Okay, we have to solve this problem around order of n m. Now how I have solved this problem, I will explain to you. Okay, so let's discuss the solution approach. uh, so I am finding two different, you can say two different subsequences. Okay, so two different subsequences in two different direction. Let's say we are finding is subsequent a segment in this direction, and we will find this direction or segment also, this direction segment also, and this direction segment also. So we will find four type of segment in four different directions. Okay, and also we can find two types of segments. One is which starts with 1, and another one which does not start with 1. Okay, so we have four different direction segments and two types of segments. Okay, two types of segment, one which will start with 1, and another one which will not start with 1. Okay, so let's jump into the code. So this dij will denote the directions. Okay, di1 1 means that, let's say we are some certain grid. Okay, we are at certain grid, and 1 means that we will go into this direction. Okay, this direction, because I value is getting incremented and j value is getting incremented also along this diagonal. So we have 1 as dij, and we are mapping this direction as the zeroth direction. Okay, now for each and every direction we are calling the function. Okay, so what this function does, it calculates the value of dp dpij dpij direction could be 0 1 2 or 3. Okay, and the values dpij di, and there is another value f. Okay, what is f? F equals to 1 means, we are at a segment, a subsequence which starts with 1. Okay, if equals to 1 means that the subsequence will start with 1, and if equals to 0 means that it can start with either 0 or 2. Okay, so let's find out the value for f equals to 1. Okay, now if the grid ij value is 1, we can say that we can have a sequence starting with 1. So dpij direction 1 will be 1. Okay, now otherwise if the grid ij value is not 1, it would be either 2 or 0. Now we are checking that the previous value we are coming from, let's say we are at this cell, so previous index, previous cell we are coming from will be pipj. Okay, this cell. So we have found that cell, and we are checking that if that cell is valid, and uh, we have a valid sequence starting with 1. Here we have a valid sequence starting with 1. Then what we can do, uh, we can we are also checking that if the current value is grid ij value is 0, then the previous value is 2. Okay, why? Because a subsequent starting with 1 will always have 1 2 0. So 1 2 0 2 0 like a structure. So let's say our grid ij value is 0, then the previous value should be obviously 2. Okay, so if grid ij is 0, then we are checking that the previous value is 2. Then only we are marking dpij direction 1 as the previous value direction plus 1. And now if grid ij value is 2, then we have two choices, right? So it could have the previous cell value as 1, or it could have the previous cell value as 0 also. So we are checking that if the previous cell value is either 1 or 0, we are marking the value of dpij direction 1. Okay, now here comes for direction 0. Now here for direction 0, what we are doing is that we are checking, initializing it with if the grid ij value is not 1, then we are initializing this value with 1. Now similarly, like the above condition, we are checking if the previous cell is valid, and here we are checking that if the current value is 0. If the current cell value is 0, the previous value will be 2. Okay, so that's what I am checking, and we are marking the dpij direction value with the previous cell value. Similarly for 2, we are checking that the previous cell value is 0. Okay, that is the function case. Okay, that is the function how we are solving the dpij direction f value in a particular direction. Okay, now we have found out the dp values. Okay, so let's say now we will solve this problem. Let's say we are at some cell. Okay, we are at some cell, so we'll take this cell as a pivot element. Okay, we'll take this cell as a pivot element. So let's say we are coming from some direction where the sequence starts 1 2 0, like this sequence starts, and this sequence will go into this direction. Okay, this will go into this direction. So this is a pivot element. So we are coming from di, and we are changing to some other direction. So for mapping this, we are finding one map. Okay, so this di map will point to that, let's say we are coming from the direction 0, in which direction our 90-degree turn will be, in which direction our 90-degree turn will be, uh, that is dim will give us. Okay, so you can check how dim value is getting calculated. I'm not going to explain. You can take the directions and how, in what direction we are going from this. Okay, like if the, if we are going to this direction, we have to go to this direction. So for this direction, dim value will be this one. Okay, now we have already the dim value. Now what will you do? So this part is for finding the answer. Now if grid ij is 1, 1 could not be our preferred element. Okay, so so we are doing answer equals to maximum of 1 comma answer, because this could not be our pivot element. Now we are going to each and every direction. Now we are checking that we have some direction. For every direction we are checking that we have some sequence starting with 1. Okay, at this direction. If that is equals to 0, we just do continue. Otherwise we are doing finding the di2. Di2 will be dimension of di. Now answer will be dpij plus dpij di1, the one that subsequent starting with 1, and dpij di2 0, another sequence which does not start with 1. Okay, now another important case here is that, let's say we have some subsequence of di2 as a subsequence 0. Okay, now we could have two types of subsequence, like 1 2 0 2 0. Okay, and this is our pivot element. this is a subsequence. And another type of sequence will be 1 2 0 2 sorry, 1 2 0 2 0 and 2 0. Now in these two special cases, let's say this is the pivot element. So if we take the sequence starting from 1 here and the sequence starting from 0 here, okay, then we are counting this 0 value twice, so we have to subtract once. But in this case we are only counting this pivot element once, so we don't have to subtract. So we'll check that if dpij di2 is greater than 0, then we'll subtract this value. Okay. uh, I hope you understood the solution and code also. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. Also, I will share the code in the description box. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.